So scientific notation is just a form of expressing functions. So once we know we have a function, a rule that applies one input to every output, basically that's what a function is. When we have such a rule, we can write it in function notation. Okay? So let's write this down. Okay? So function notation is a form of expressing a function. In the form of an equation. Okay. So after that, I think I should give you an example of what it looks like. Kind of the big introduction. So this is the big reveal. So this is what a function notation looks like. The most common one, by the way. Okay. And it's going to seem like, what? This is it? So just go ahead and write that down. Take it all in. You got an F and then in parentheses an X. Okay. And what this means, literally it means f of x, like this, I'll put it in quotations, means the function and then f of x. Okay? It means the function f of x. If I had a different letter instead of f, it would mean, say I had g. G is another common variable we use here. The function g of x, or the function h of x, or the function, it doesn't even have to be x. In physics, they like to use the function m of v. It's just a way of telling you we have a function. Whenever you have a variable and then parentheses something else like this, you're not saying multiplication. So that's the very most important thing. What did we learn maybe last year, the year before, or maybe even this year? What do parentheses tell you to do mathematically? Yes. Yeah, do anything and then first, like when we were distributing, right? What would we do? What mathematically? What would we do? What operation? Yeah, we would multiply. Remember? And a lot of times we do multiply with variables, but not in this case. So this is very important. We should point this out, and I'm going to highlight it and make sure everyone understands this. So this is kind of like, let me write it in red. Okay. F of x does not mean f times x. That's not what it means here. All we're saying is we have a function. Don't know why I put quotes there. All it's saying is we have a function. That's all it's saying. We have a function. Okay? It's a way of letting people know we're dealing with a function, so we're going to work with it in a certain way. Okay? Now, basically, I'm not going to show you any new type of math, any new rule, or anything like that. I just want you to get comfortable with this way of writing functions. Okay? That's all it is. So let's look at some other examples of common functions in this function notation. Okay? Well, so let's just say also functions. Also in function notation. This function notation stuff is just going to follow you year after year. This is the first time you've probably seen it, I'm guessing. But it's going to follow you year after year in your math career, in your algebra classes, 1 and 2, probably even in geometry, definitely in pre-calculus and stuff like that. And if you take physics classes, which many of you will in high school, they'll throw some functions in there too. They like to play around with these too. Okay, so these are some other popular. Okay, so this one. Everyone say it with me, please. G of x. Okay, we're not saying g times x. We're saying the function g at x. That's all.
Why not times x because of the parentheses?
Well, because we're saying we have a function. We're not saying multiply. We're saying this is a function. When you see the whole expression, you'll see why. Okay, so g of x, that's another popular one. H, they just kind of follow after f. H of x, that's popular. I've seen k sometimes used. K of x. And in physics, they like to use motion in some variable of time. So m of t.
Wait, why is everything different? Why are there x's and then?
Well, here in physics, physical science, they like to deal with motion and stuff, and motion over time. So here the t represents time, and m represents some amount of motion or distance.
Well, because those are function notations.
Yeah, this is for pure math, and this is more physics. This is the science realm. Another one from science, v of t. What do you think the v stands for? Velocity. How your speed over time. Okay, so here is the big reveal. You ready? Another big reveal. Remember yesterday we were talking about independent and dependent variables? One of the reasons we like to use this function notation, it tells us which one is the independent and the dependent variables depending on where they are in this function notation. So for independent and dependent, okay, let's say we have f of x. The function f of x. That's the most popular one. Okay, here's the big reveal. You see the x inside? That's the independent variable. Okay, that's the one it's independent of anything else.
And the dependent is f.
And the dependent is f. Usually it would be y, but we're substituting it for f. Okay, or f of x completely dependent. Okay. So that's one of the reasons we like this is it completely makes it clear what's our independent and our dependent variables. Okay, so let's go ahead and write down a complete rule with this function. Okay, so we're going to write something in function notation now, and we're going to work with it. Do a little math. All right. Nice and squiggly there. And here is a function we're going to work with. F of x equals 2x plus 1. Go ahead and write that down. F of x equals 2x plus 1. All right. So this is how we use this. It looks like any other equation we've worked with, except we're substituting the y with f of x, or the function at x. Okay? Now, what is the rule telling us to do? Mathematically, what do you think the rule is telling us to do? Well, we're not going to solve anything. Just, it's telling us if I put in a number for x, what do I do mathematically? It'd be 2 times x and then add 1. Yeah, plus 1. That's all it's telling us to do. Multiply 2 times whatever x is and add 1. And spit out that number. Think of it as kind of like a little machine. Put something in, you get something out. Okay? So we're going to make a function table with this function. All right? So let's make a, a function table. So let's see here. We're going to make a function table. Let's write that down. Function table. So we'll start with a function table. The rule for the function is 2x plus 1. Okay, so let's see here. Make it quick. And we'll do x on one side and f of x on the other. Okay, so we'll have this one.
Did you say fx and not just f of x? Or just...
Yeah, f of x, fx. Whatever feels good off the tongue. Okay, so let's pick the numbers 1, 0, 4, and 8. 1, 0, 4, and 8. Just because they're independent and I picked them. Good question, though. I like it. Remember, x is the independent variable, so I can choose any number, but sometimes it's good to pick certain ones, and I didn't want to make them too big. Okay, so all we're going to do is apply the rule. Okay? So we're going to apply the rule for f of x. So this is what we're going to do. We're going to plug in 1, 0, 4, and 8. Okay? You guys ready? First, we're going to do f of 1. Right? Because that's what we have there. So it's 2 times 1 plus 1. And we'll get an answer. 3, right? That's 2 times 1 plus 1 is 3. So this is 3. Then we'll do f of 0. You see how I'm writing it? And then it's 2 times 0 here plus 1. So wouldn't that be just 1? Yeah, because that's 0 plus 1. You get 1 there. You get 1 there. Then we want 2 times 4. So we want f of 4. And that would be 2 times 4 plus 1, which equals 9. And then we'll do the last one, f of 8, which is 2 times 8 plus 1. How much is that? 17. Yeah, so 2 times 8 is 16. Add the 1, 17. Okay, now, if we needed to write these as ordered pairs, We've done a bunch of those. So let's express these as ordered pairs. Like Santiago said, 1, 3, 0, 1, 4, 9, 8, 17. Now,
Oh, I see what you're doing.
just took these, wrote them as ordered pairs that we can graph.
This isn't hard.
Yeah. It's not, none of the math is anything we haven't done before. It's just kind of doing it in a different way. Now, the last format that we're going to list this in is in scientific notation. So there's a way of listing your ordered pairs in scientific notation. And it's basically taking this first part here and this part here where you got your answers, putting it together, okay? So we're going to list the last format in scientific notation. I'm sorry, in function notation. I get too many notations on my brain. Okay, so this is how it's going to look like. If I wanted to write 1, 3, because that was our answer, and f was the function, I would write f of 1. Well, we just want the answer though. F of 1 equaled 3. Basically, you took this part and put them together. But all we really need to get that information is the ordered pair, right? So let's take the ordered pair 0, 1. F of 0 equals 1. F of 4 equals 9. F of 8 equals 17. Okay.
So we have to write it like that?
Not necessarily. I just want you to get the background because it will come up.
So then what will we write?
We'll be working with the function tables mainly. IXL. Okay, so let's do 2 of these. We're going to do 2 function tables, and then we'll express the answers as ordered pairs and functions. We won't necessarily need to redo this again. I just wanted you to see how the math worked and how we got from this to this. Okay? So we're going to do this part again with a couple of different functions. You guys ready? All right, let's do it. So let's do number 1. So we're going to write this in a function table, ordered pair, and as a function. Okay, so let's do one, call it g of x. And the rule for g of x is going to be g of x equals negative 3x. Okay, so we'll make a function table for that. So let's do x on the table, g of x, and let's do negative 1, 0, 1, and 2. We'll go in order this time. So let's think about what the rule is telling us to do mathematically. Yeah. Just look at this side and it'll tell us. It's negative 3, and then what do we do with that negative 3? Do we add, subtract, multiply, divide? Multiply with whatever x is. So it would be negative 3 times negative 1. Okay, what's that going to give us?
Positive 3?
Positive 3. Then we would do negative 3 times 0.
No, 0.
0. And then you were thinking the next one, negative 3 times 1, right? That's negative 3. And then we'll do negative 3 times 2, negative 6. So now that's the function table. Let's do the ordered pairs. Okay, so those are the ordered pairs. So we did a table, ordered pairs. Now let's do function notation. You have to be careful though. How would we write our first ordered pair in function notation?
G of 1, negative 1 equals 3
G of negative 1
equals 3.
equals 3.
Oh, okay.
Yeah, you're literally just taking these numbers.
G of 0
G of 0 equals
equals 0.
0. Okay? All right. We'll do one more and we'll call it number 2. This time we'll do a quadratic. We'll call it h of x. Oh, these? Usually not unless you're like I said in science, they mean something like motion, velocity, mass, no, not mass, force, acceleration, things like that. They would use those type of variables. So they might use a v for velocity, um, t for time. All right, so this one, let's make it x squared plus 1. Okay. All right, so let's do x and h of x. So we got x over here and h of x over here. And we'll do negative 2, negative 1, 0, 1, and 2. So this one is quadratic. So we're going to have that symmetry that we saw last time. Okay. So let's look at the rule though. What's the rule telling us to do this side?
To divide?
Multiply the x by itself, squaring it basically, and then adding 1. So that's what we'll do with a negative 2. Multiply negative 2 times negative 2, then add 1. So negative 2 times negative 2 is 4, right?
4.
So plus 1 is 5. So we're going to get a 5 here. Okay, let's do it again for negative 1. You're going to get, yeah, it'll be 2 because negative 1 times negative 1 is 1, positive 1. And then you add the 1, you get 2. Let's do that for 0. That's 1. 0 squared is 0, plus the 1 is 1. And then we're here at 1, you square it, and then add 1. 2 again, right? That's that symmetry that we get from these quadratics. So what do you think the answer is for 2? 5. Yeah, 2 times 2 is 4, plus the 1 makes 5 again. So let's get the ordered pairs. Remember, this is a function. Even though the y's are repeating, it is a function. And if you go into advanced algebra classes, you'll...
Why is it a function even though it's the y's are repeating?
X's are the ones that can't repeat in the function.
Yeah.
What it is, it's not a one-to-one and onto function. But that's like, if you ever become a math major, then you worry about that. Okay. Negative 2 and 5. Negative 1 and 2. 0 and 1. 1 and 2. 2 and 5. There's our ordered pairs. This time in function notation, we're using h. So this would be h of negative 2 is 5. H of negative 1 is 2. H of 0 is 1. H of 1 is 2 otra vez. And H of 2 is sank. All right. So that's function notation in a nutshell, guys. Any questions? So the assignment is going to be on IXL, and it's basically working with the tables, function notation and tables.